students, in previous video we have seen two types of solids, crystalline solids and amorphous solids. Also we have seen different types of crystalline solids. In crystalline solids, how crystal structure is made, it can be explained in today's video. In today's video we will discuss about crystal structure. Crystal involves different terms and we have to know about these terms. First, lattice. What is lattice? The geometrical arrangement of points in a three-dimensional periodic array. It is called lattice, the geometrical arrangement of points in a three-dimensional periodic array. It is called lattice. Next term, lattice point. What is lattice point? A point of intersection. Point of intersection of three axial edges of a unit cell to which the constituent particle is attached. Say for example, this is unit cell. This is unit cell. Suppose these are axes, x axis, y axis and z axis. The point where all these three edges of the unit cell intersect each other, it is called lattice point. Next, space lattice. Space lattice. What is space lattice? A collection of lattice points of unit cells with same environment. in space It is called crystal space lattice or also crystal lattice. Now see, this crystal lattice, only lattice points in space can be shown by this way, and number of unit cells when joined to each other, they can be written in the form of space lattice. Only a collection of lattice points in unit cells with same environment in space is called space lattice. Crystal lattice. What is crystal lattice? The structure made up of three-dimensional strips of unit cells, which cross each other diagonally. The structure made up of three-dimensional strips of unit cells which cross each other diagonally. Now you see the structure. Suppose this is unit cell. This is unit cell. When number of such unit cells are arranged or joined to one another in three dimensions, first of all strips of unit cells are formed. These unit strips are arranged one over another and crystal lattice is formed. On joining number of unit cells in three dimensions, such crystal lattice is formed. In this way, number of unit cells when arranged in the vicinity of one another in three dimensions, strips are formed in one dimension, two dimension, and when these strips are arranged one over another, a three-dimensional structure is formed. It is called crystal lattice. This is crystal lattice. Next, we have to discuss about crystal structure. What is crystal structure? A structure obtained by particle. Constituent particle to each of the unit cell or each of the lattice points in the unit cells a structure obtained by attaching constituent particle to each of the lattice points in the unit cells. These are lattice points. And if we show lattice points here, in this way, when lattice points are shown in the crystal lattice, it becomes crystal structure. Another term is there for fifth term, basis. What is basis? When constituent particles the constituent particles that are attached to the lattice points are basis of the crystal lattice. Or in short, you can say the constituent particles which attach lattice points in the unit cell is called basis. Every constituent particle forms basis by attaching itself to the lattice point in the unit cell. Next, we have to discuss about crystal. What is crystal? A structure. A structure which is formed by attaching a basis, or you can say constituent particle. To each of the lattice points of the unit cells. A structure which is formed by attaching a basis or constituent particle to each of the lattice points of the unit cells, it is called crystal. Now formation of crystal can be explained. These are space lattice. This is space lattice. Base, that means constituent particle attached to the lattice point. It is called basis. First of all, constituent particle occupies lattice point forming base. And then these unit cells are joined to one another forming crystal. Then next task we have to discuss about unit cell. What is unit cell? The smallest three-dimensional basic repeating structural unit. Structural unit of a crystalline solid. Crystalline solid which cannot be broken down further. A smallest three-dimensional basic structural unit of a crystalline solid which cannot be broken further. It is called unit cell. Now explanation of unit cell. First point, it is the smallest basic structural unit of crystalline solid. Second, space lattice, or you can say crystal lattice, is always built up. Is always built up of three-dimensional basic pattern of unit cells. Third point, the basic pattern of unit cells is repeated in three dimensions to generate crystal. Fourth point, when the unit cells are stacked or joined together in a definite geometrical pattern, to generate crystal. Each unit cell shares its faces edges and corners with its neighboring unit cells. Unit cell is the smallest three-dimensional structural basic unit of any crystalline solid which cannot be broken down further. Space lattice or crystal lattice is always formed or it is built up of three-dimensional basic pattern of unit cells. Basic pattern of unit cells is repeated in three dimensions to generate crystal, and when crystal is formed by stacking of unit cells together in definite geometrical pattern, every unit cell in the crystal shares its faces, edges and corners with its neighboring unit cell. Next point, geometry of unit cell. Geometry of unit cell is same as that of the shape of as that of the geometry of macroscopic crystal. geometry of crystal depends upon geometry of unit cell. Geometry of crystal is always same as that of geometry of basic unit cell in the crystal. These parameters of unit cells can be explained like this. This is unit cell. Here this is A age length, this is C age length, and this is B age length. We consider this corner. A, B, C are ages. Then these are faces and angles. Alpha, beta, gamma. Alpha, beta, gamma are axial angles. And this is corner. In this way, in any unit cell, you can show these parameters such as ages A, B, C. They may be same or different. Faces depending upon geometry. Axial angles alpha, beta, gamma. At any corner you can show it as per shown in the diagram. Now next point we have to discuss about types of unit cells. Types of unit cells. Depending upon the constituent particles occupied at the lattice points in the unit cell, there are four types of unit cells. First, primitive or simple unit cell. What is primitive or in primitive or simple unit cell? Constituent particles, the constituent particles are present only at the corners of the unit cell. This is very important one. In primitive or simple unit cell, the constituent particles are present only at the corners of the unit cell. For example, simple cubic unit cell you can show. This is unit cell and these are corners of the unit cell. And constituent particles are present simple cubic unit cell. It is abbreviated as SCC. Second type, body center unit cell. In body center unit cell, one constituent particle is present at the center of unit cell. In addition to the constituent particles present at the corners of the unit cell. In body center unit cell, one constituent particle is present at the center of the unit cell in addition to the constituent particles present at the corners of the unit cell. You can show body center cube like this. This is cubic unit cell and these are constituent particles present at the corners of the unit cell. This is now simple or primitive unit cell. If you show one more particle at equidistance from all the 8 corners of the unit cell, that means constituent particle is present at the center in addition to constituent particles at the corners. This is called body center. Cubic unit cell. It is abbreviated as BCC. Third, base center, or it is also called not base. First of all, you see phase center. Phase center unit cell. What is phase center unit cell? In phase center, unit cell, the constituent particles are present. Constituent particles are present at the center of each of the phases. In addition to the constituent particles particles present at the corners of the unit cell. In face center cube, now you see, this is suppose unit cell. This is unit cell. These are the corners, constituent particles present at the corners of the unit cell. Now there are 6 spaces in cube. At the center of every cube, it will show one particle. Front particle and back particle. At the center of every particle, it will show this part. In this way, front, lower, upper, lower, left hand side, right hand side. Here you can show one more particle at the center of front face and one particle at the center of back face. This is face center arrangement. 4. Base center, or it is also called end center. Unit cell. In base center, unit cell, 2 constituent particles. 2 constituent particles are present at the center of any 2 opposite faces. In addition to the constituent particles present at the corners of the unit cell. Now suppose this is monoclinic unit cell. This is monoclinic unit cell. These are corners or constituent particles at the corners of the unit cell. This is simple arrangement, but if you show particles at the center of any 2 opposite faces, it becomes end-centered, or this is monoclinic base-centered In this way, there are four types of unit cells depending upon arrangement of constituent particles at the corners, at the center of the unit cell, or at the faces. There are four types: primitive or simple, in which constituent particles are present only at the corners of the unit cell. Body central unit cell. Here, one constituent particle is present at the center of the unit cell, in addition to constituent particles at the corners of the unit cell. Third, face-centered unit cell, in which constituent particles are present at the center of the faces, in addition to particles at the corners. This is the arrangement. This is face-centered. Cubic unit cell and can be abbreviated as FCC. Face center. And last one, base center or end central unit cell, in which two constituent particles are present at the center of any two opposite faces, in addition to constituent particles present at the corners of the unit cell. In next video, we will discuss about Bravais lattices. Thank you.